Hello everyone and welcome to the Certara University webinar series. And the topic for today is how to extend steady state simulation to combined dosing regimes in Phoenix. My name is Chandramouli Radhakrishnan and I'm a support analyst in sector at Certara. And I'll be presenting for this session, and I'm also joined by our panelist Hannah Henry from Certara. Just going through the webinar logistics. So I'll just want to talk a little bit about this seminar is being set up. All the participants are muted on the audio, and this is a 30 minutes webinar with 5 minutes Q&A session. On the right-hand side of your WebEx window, you could see a panel for Q&A. If you have any questions, please type your questions on that panel. Just going through the overview of this webinar. To give an overview on what we talk about today is simulation of steady state using Phoenix WinOnLin. The underlying assumption is achieved by a good PK parameter estimates are available from modeling single dose data or from the literature. We talk about how to set up input data file structure for simulation, building Phoenix model object for steady state simulation, using steady state flag, which is a feature of Phoenix model object to see whether the associated dose is a steady state dose. We'll talk about how to specify the simulation model setup, and I'll perform a software demonstration how to use the steady state option. Then we will review the results followed by a Q&A session. So when you flag steady state option, it indicates whether the associated dose is at steady state. Also, it assumes to be the dose at regular time and the steady state is reached. Glossary of terms used in this webinar. So time, delta 1, delta 2, which are the times of the dose of administration. AA1, which represents the extravascular dose amount for AA, and A1 is the IV bolus dosing amount. And the other option is SS, a steady state option. COBS, observed concentration. C, predicted concentration. So the input file structure required column is your time, dosing amount, AA or A1, steady state SS, AA1 and delta 1. The option columns could be the regimen, COPS, EOPS, II, or ADDL. So as you can see, this is an example input file to simulate steady state concentration after a single dose administered every 24 hours. When you're doing a steady state simulation, SS flags need to be numeric, as you can see here. If value equals 0 or blank indicates it's an ordinary dose, and you will not get a steady state simulation. If it is greater than 1, which indicates that prior dose is given and PK model is put into steady state mode. So the Phoenix model object, the PK/PD compartment model simulation are done using Phoenix model object. The Phoenix model object can be added using the insert and a right click on the send to menus, as you can see in this picture. Once the structure of then the second part is going to be mapping the data column. So which you can see up here where you can map a sort by ID, and if it's a dose, amount is mapped to dose A1 and the time to time and COPS to CO concentration. So Phoenix, once the Phoenix model object is being mapped, you could see the structure tab. In the structure tab is used to set up the Phoenix model. In the type menu, you could select the type of Phoenix model from the drop-down menu, and the parameterization is clearance, or you could have other options in the drop-down menu. And the absorption is going to be intravenous or extravascular, and the number of compartment can be defined as well. So this is followed by the parameter. The parameter consists of 6 sub-tabs that allow user to modify the structural parameter, specific value for fixed and random effects, and add covariates. So in this steady state simulation, we will be interested in more in mapping it on fixed effect tab. The fixed effect tab allows the user to enter the initial, lower, and upper values for fixed effects. So the next option we'll be looking at is the input options, the next tab. The input option tab allows the user to add extra mapping contents like MDV, steady state, ADDL, or data value. So in this, when you're mapping using a steady state option, we have to check the steady state checkbox if the main input data contain a steady state column. Selecting a steady state displays the steady state subtab, which allows us to add new steady state treatment sequencing item, and the main mappings of the panel and converted fixed effect units is being done there. So in this, we have 3 options. One is your dose point, where you would add AA or A1 if it's going to be an infusion dose, and we have to enter the column amount, and then the delta time is up in the third option where we have the delta time. So, and the final option is going to be a run option tab, where the simulation mode can be specified. And in this example, you can see 2 options. Either you can use a number of points, or you could have a simulation table with a sequencing of time and period, and with a variable concentration. So once we have all these options and we simulate, after running a simulation, the output plots are produced. As you could see, an output spreadsheet of a predicted time concentration is created, and that can be used to produce further plots or tables. When you do a steady state option, this is a good comparison about doing additional dose and with a steady state. As you could see in this picture, there's once a day dosing is being done with a steady state option, and the concentration at 24 hours is being measured. Similarly, on the right hand side, you could see with the BD dosing how the steady state is being simulated. And we could add more options with the steady state option. You could add ADDL with steady state. So you could combine these 2 options together. Either you could have with the same dose. So in this example, in this picture, left-hand side picture, you would see the same dose is being given, or you could have with a different dose. So before we go into the demo, I just want to briefly explain what we are going through in this case. It's a chronic pain relief medication is being studied at high concentration. There is a risk of side effects due to toxicity. A PK scientist wants to predict a steady state profile for 3 different regimens of the same total daily dosing, QD, BID, and TID. And we do a single dose PK data is not available according to the literature. The drug follows 1 compartment model, and with the following typical values for PK parameter, which is Ka of 1.2, volume of 300, and clearance of 20 mL per liter. So in the Phoenix model object, the SS option will be used to perform multiple dose simulation. So I'm just quickly going to share my screen and we'll quickly start the demo. Yeah. So this is a typical example for where we have for which we use for ADDL options, where some of these are required column, which is a ADDL, II, and we don't need any SS, which is a steady state simulation option with ADDL. So I could add this as once a day dosing. If I want to add multiple, so I just need to change this one to text. Already. And I'm just going to add a few more rows into this one. This is going to be a BD dosing with the same amount with 3 additional dose. And this is happening every 12 hours. And the time is going to be 0. And one more for 3 times a day with the same dose of 6,000 microgram. And 3 additional doses. And the delta time is going to be 8 hours. And the starting time is going to be 3. So I'm just going to map it to my Phoenix model object. Either I could right click and send the data to Phoenix model object. I've already created a sample data, so I'm just going to use that one. And I could send this or drag and drop it to this particular mapping field. So the AA is mapped to the AA dose amount, and then you got the time, and we have to specify the additional dose. I'm just doing it in a non-population mode, so I'm just going to sort it by regimen. And up in input options, I do have clicked ADDL, and either I could use a column mapping or I could use a constant mapping. So in this case, I'm just going to use a column with a dose point of AA. Since I'm using an oral dose, I'm just specifying this as a bolus. This can be altered if you're using an IV infusion. And the amount I'm giving is about AA, which is 6,000. So once I've done that, under the run options, I'm just using a simulation option. And approximately I'm using 145 points with a maximum range of 300, and the C is my concentration variable, or I could add a simulation tab, which would create another additional tab which can be used later on. Under parameters, I'm just going to, under fixed FX, so based on the example what we have, I have mentioned, we have a K of 1.2, volume of 300, and the clearance of 20. So once it's all ready to go, what I'm going to, so you run the project file. So now we've got 3 different outputs. So I'm just going to use this, and when I do my steady state, I'm just going to compare against these 3 options. Compared to ADDL, when you're mapping the dose or when the dose file is being set up, it's slightly different to the ADDL options. If you could see, everything is done in row, whereas if you're doing steady state options, it is done using a column mode. So I've got AA, which is my dose, and the delta time is going to be 24 hours, and 6,000 is going to be AA, and I just want to measure the concentration at 24 hours. This can be changed to 24 or 48, so whatever way you want it to do. And I have to have this particular column, which is a must for steady state, and the numerical, it's a numerical column, and have to say 1 or anything more than 0. So once I've done that, I'm just going to send this into the project file. I'm just going to drag and drop it. So I've got all these options set already available which is ready to go. And if in this steady state option, I don't require II, so which is required in ADDL option. I don't need ADDL as well. Under input option, under parameter options, I've got my Ka volume and clearance already set to go. And with input option, I'll be selecting a steady state in this steady state. And the dose point is going to be AA. So where we are entering the dose point name, and we are going to choose the bolus in this case because it's an oral dose. And enter the column name for amount, which is going to be AA1. And then the delta is going to be the time difference for every 24 hours. Under the run option, I would prefer using a simulation tab where I'm setting up a sequence of sequence option, and the variable is going to be C. So with this one, once I run that, so I got the table one being done. So to look at the output, I'm just going to send it to a plotting option and see the time. It's going to be plotting against time and concentration. So this would give a nice output for me. And just going to do some modification with this one. I've got this one. So now I'm going to combine this with my ADDL output and see what's happening at 24 hours. Just need to slightly tweak this one using a data wizard option. Sorry, using data thing where I'm going to split the worksheet. And splitting it by region. I'm just going to add my once a day dosing to this XY plot. Run TV. And with this option, I'm able to see the steady state that is happening around 24 hours, which is exactly what we see in the presentation. Similarly, you could do it for twice a day dosing and 3 times a day. So I'm not going to spend much time on that one, and I'm just going to go into the next option where you could combine 2 different doses, or you could use ADDL and steady state options. So if you're combining both ADDL and steady state, the data structure is slightly different. So you have same dose, which is around 6,000 microgram, and 3 additional doses, or you can increase up to 5 or 6, and it is being dosed every 24 hours, and the time at 0 hours it's being given. And for the steady state option, I have the delta as 24, and I'm slightly increasing this dose to 1,200 just to see what difference I'm getting. So in a clinical scenario, if you want to increase the dose from the current steady state to the, and you want to change the dose, that can be done using this option. And the time I'm going to have it is around 200 minutes, 200 hours. So just going to send this data back to this one, and I've got all these options selected. So since I'm using under the input option, I've selected both steady state and ADDL. So since I've selected both steady state and ADDL option, so I have to map all the available parameters here, and both here, so the ADDL is being selected, simultaneously the SS is selected. So And I've defined all these columns up here. If it's going to be a column, or you could change that into a constant, whichever way you want to map the data in. So that can be done here. And the run options, I'm just leaving it as it is at the moment. So if I want, I can add a simulation tab, and I felt this is a bit more easy for me or convenient for me to do in this particular demo. So once I've defined the run option and the simulation option, I'm just going to run the project file. So up at the individual simulation, what I could see is I've got the concentration building up over a period of time, and around 200 hours, I'm dosing the subject with 1,200 microgram, and I could see the different peaks coming up. So what it is assuming is anything before that is going to be at steady state. And if I want to change my dose into 6,000, so if I want to increase or decrease, and if I want to change the time, everything can be done up here. Say 250 hours. And if you go up into the option here, change it to 250 should be fine. I'll just make it to 350. So this will produce a nice graph. As you can see, the peaks are all same. And what it's assuming is any dose before that, I'm just going to get the same. It's assuming that the steady state is reached, and it's producing the steady state concentration at that particular time. So you could do multiple things using these steady state options. So just going back to my slides. So moving forward, what we could do, additional things we could do is, so you can add multiple dose. Multiple dose after steady state. So in this case, I can add a dose at 6 hours. As you can see, the peak is going up. These options can be done as well. And if you want to combine this with additional, ADDL, that option can be done. When doing these kind of options, so I'm just going to quickly show how the data is being set up. So I'm just going to have in this example where I have got two different doses where I have to define delta 1 and delta 2, and I'm having the 3 additional doses, which is followed by my delta 1, which I'm dosing it at 24 plus 6 hours, and then the next dose will be at 18 hours. So you have to calculate at what time you're giving. So that has to be done using that can be done as well. And the way you have to structure it is seen here. And you could see the output which I showed. So this is the output you're getting. So you're dosing at 200, and then 206 hours, you're dosing another dose. You could see these options coming up. This concludes a small demonstration how you could use the steady state option in Phoenix Wind non-limb. Up at Certara, we've got few more webinars coming up. As you can see, the dates are up here, and you can register up at Certara University. Yeah, if you have any questions, Anna, is there any questions for me?
Thank you, Muli. I do not see any questions on the Q&A, so if you have any questions, please type them in there. Okay, to access the Q&A panel, if you don't see it, you may need to go to the bottom of the presentation. There's a circle with like 3 dots that says more options. And if you click on it, you will have an option for the Q&A panel. No, I do not see any questions coming in. Okay, I do have one question right now asking if we will be able to share the recording of this webinar. And I'll just answer that. The answer is yes, we are recording this webinar. We'll make it available. We'll send you a link, and you will be able to rewatch it. And we'll put this in a course at Certara University, and we will share the file that has been shown. All right, there's a few more questions coming in. Molly?
Yep. Change.
Okay, so give me just 1 second. All right. Okay, one question asked if the PK parameters that we were looking, they were not able to be changed. So when you were showing the Phoenix model, and you went to the fixed effects, those parameters were grayed out. So the question is, why were they grayed out?
All right, it was not grayed out actually. That can be changed. Just going back here quickly, looking at these input parameters. So these can be changed. Actually, you can change the parameter. I think it's because of the screen resolution. You may not, it looks as though it's grayed out, but yeah, you can definitely change these PK parameters. These can be definitely changed. It's not grayed out at all.
Okay. The next question is about, can we use the same predictive method for both linear and nonlinear PK? So can we simulate using these options of ADDL and SS if we have nonlinear PK?
I think it's mostly for linear PK.
Okay, and the last question is for webinars related to QSP. So it's not part of this series, but we sometimes do offer some scientific webinars that are related to the QSP area. So if you sign up for Certara webinars, the scientific webinars, you can even look at the archive, and there's some topics that relate to that. They're not going to be part of this series. This series is going to be discussing intermediate topics in Phoenix, both with NNLIN and NLME. All right, so I think that's the end of the questions. I don't see any more. Oh, okay. There is one more. I'm sorry. There's just one that came up. The question is, the additional dose is after SS. Just give me a second. I think that the question is somehow not, the full questions didn't really come through. So whoever asked this question, if you can type it again, it just came out truncated. So I'm not able to see it. Okay, yeah, it came in right now. So the additional dose is after SS. Why did the plasma concentration still start from 0?
I think this is a known issue with Phoenix at the moment, and we are trying to get that one resolved. So that is one of the reasons I was using to create a simulation tab. So if you're using both ADDL and SS option, I think you have some options, concentration starting at 0. So you have to use the workaround for this is going to be using the simulation option, the table sequencing, the additional table.
Okay, we have a couple more questions, but I think this is the end of the time that we're allowed it. As we provide you the recording, we can also address the rest of the questions that came in a little bit late. So if you asked a question that wasn't answered here, we will do that in writing at the time of the recording. So this does bring us to the end of this webinar. We're going to adjourn now, and thank you for attending, and we hope you join us next month. Thank you very much.
Thank you.